Okay, so this is section 4.3, continue with part 2. We're going to look at now the concepts behind the horizontal and vertical lines. So all of our lines that we've drawn so far have been slanted. Okay, and last day we looked at graphing equations in what we call general form. So that was an example like this. Remember x plus y equals 10, where all our variables were on one side of the equal sign. So today we're going to look at variables, or not variables, but linear equations that only involve one variable. See, all the other ones had two. Now let's take a look at what happens when there's always one. So let's consider this relation. Y is always equal to 4. So as an equation, this translates into y is always equal to 4. And by the way, if you want to write it as two variables, you can. That's 0x plus y equals to 4, but why waste your time and ink and everything else? Well, if y equals to 4, I want you to create a table of values for 3 different values of x. So remember what I said was y is always 4. So 4, 4, 4. What value of x do you want to choose? Well, really, it's up to you. So 0 perhaps? 5 perhaps? A negative 2 perhaps? Sure. It doesn't really matter what value of x I choose as long as the y value is always 4. Now the question is, how do I graph this data then? Well, as a coordinate this becomes 0, 4. As a coordinate this one becomes 5, 4. And this one becomes negative 2, 4. So graph them all out. 0, 4. 5, 4. Negative 2, 4. And should you join the points? You bet. So, of course, because decimals are okay too. Could have had negative 1.5, right? That's the 4. And so notice what type of line you get. Wow, it's a nice straight horizontal line. So what unique properties does this have? Yeah, you're right, a horizontal line that is parallel to the x-axis. That's cool. Does it have a y-intercept? Yeah, it does. A y-intercept. That's where it crosses the y-axis at 4. Does it have a horizontal or x-intercept? Don't see it, so no x-intercept. Those are some unique properties. Okay, how about the next one now? How about the equation that only involves x? So now let's consider this equation. X equals negative 3. You could also write this as x plus 0y equals negative 3, but once again, why waste time? So in this case, no matter what number we select for y this time, x is always equal to negative 3. So if I ask you to make a table of values, look, this time I'm saying the x value is always negative 3. You choose whatever y value you want. So 0, 2.5, negative 5. Sure, whatever else you choose. And go ahead and plot these points. So negative 3, 0, right here. Negative 3, 2.5, right there. Negative 3, negative 5, down here. And if you join the points, which you should, interesting. What type of line do we have here? Can you say vertical line? I can. So in this case, it's parallel to the y-axis. Interesting. X equals to is a line that's parallel to the y-axis. Does it have a y-intercept? Does it cross the y-axis here? No. It's parallel to it, so no y-intercept. But because this is an x-equal equation, I think there's an x-intercept. Yeah, there's an x-intercept, though. What value? Negative 3. Cool. So what can we learn or summarize from what we've just done on page 1? We'll turn the page. And to summarize, if I have a graph where y equals to some sort of number, okay? Y equals to a number. What type of line do I get? Well, it's a horizontal line. And because it's horizontal, it has a y-intercept. And if I have a graph that's x equal to a particular number, it's a vertical line. In this case, with an x-intercept. And when the graph has two variables in both x and y, we have a slanted line. And that's what we've learned in the previous few lessons. Okay, that's it for lines. So can you now try and just graph each of the following on the same grid? 2 and 3 are today's material. Maybe we should do that first and then go back to number 1 because that's review. Okay, so maybe we'll do this. I'll ask you to do numbers 2 and 3 first and then do number 1. Okay, and I'm not going to actually do this with you. I really think you can do it on your own now. So pause the video and do it and then come back to check your answer. I mean it. If you're just playing the video, you should pause it. I won't start until you pause it. Did you pause yet? Y plus 3 equals 0. That looks kind of weird. I'm going to rewrite this as y equals to negative 3 by putting it to the side. If you want to make a table of values, that means the y value is always negative 3. You choose whatever you want for x. I'll just choose some simple numbers, 0, 1, 2. And if you plot that, 0, negative 3, 1, negative 3, 2, negative 3, connect them together, there is your line. So this is the line y plus 3 equals 0. X equals negative 5. If I just make a nice table of values, you can choose anything for y, so 0, 1, 2 again. So here what I'm saying is x is negative 5, y is 0, x is negative 5, y is 1, x is negative 5, y equals 2. Yeah, you should get your nice vertical line. So here's x equals to negative 5. And then last but not least, let's go back to this one. Up to you how you want to do this. I'm actually going to try and solve for y for number 1, which means I want to move the 2x to the right hand side. So that becomes negative 2x plus 1. And now I can make my table of values. I'll just choose some nice simple values of 0, 1, and 2. When x is 0, let's plug this in. Negative 2 times 0 is 0, plus 1 is 1. Do the same thing for 1. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. And then last one, y equals negative 2 times 2 plus 1, negative 4. Negative 4 plus 1 is negative 3. So here we go, 0, 1. 1, negative 1. 2, negative 3. And you're right, this is slanted because we've got two variables. Oops, I didn't draw that very well. Still didn't draw that very well. Okay, and that's the equation 2x plus y equals to 1. Did you get it right? Did you get it right? Did you get it right? If you did, give yourself a pat on the back. If you didn't, that's okay. You're learning right now. Just make the changes, understand what you did wrong, and learn from it.